stuff. Okay, right. So into the main presentation. So again, thank you all for hearing that. So as I said, I've been in the railways now 32 years in PWA and in the railways, and I'm still learning. This presentation, there may not be anything groundbreaking. Hopefully, it will be some good prompts for those that are still in the industry, in design, in construction, in client side. Because, as I said, I am always learning, and this will just give you a bit of an idea of some of the issues we've come across on my jobs, how we've solved them, and what we're doing taking these forward. As Jules said, our technical head of track for the Alliance, got many hats, including CEM role, technical head, and I try and lead CEMs in the ACOM. And Paul Bell is going to be my special guest for a few minutes just to talk about an issue we had on one of the projects. Okay. So, just a quick note about ACOM and the Alliance. ACOM track designers, our PWA is not just about design as part of the system. We have a big pool of staff who are multi-skilled, and in their skills includes topo surveying, condition survey, gauging input into designs. We're often involved with projects from inception through to construction, and we do a lot of site support as well with our contracting partners. Okay, and we've had jobs such as Trafford Park Line, Pudding Mill Lane for Crossrail, and some HS2 work also. We're based around the UK. We have offices in London, Swindon, Birmingham, Manchester, York, and we also just opened up a design house in India. So that's recently opened, and they will be taking some work as well for the UK. We are specialists in feasibility to detailed design, as well as high-speed alignment work. And we also have CEMs. As I said, I am a CEM. So we have CEMs, CREs, and licensed gauging engineers also, and very skilled topographical engineers and condition assessment people. We're about 50 plus staff strong. And again, if you hopefully, you know our background, we were British Rail, we then became Scott Wilson, then URS, and we are now ACOM. As part of the 50 plus staff, PWA staff, we have a core of staff that work in the South Rail Systems Alliance. So as well as all of the sort of non-alliance projects, we have the alliance projects, which encompasses other projects, which I'll get onto. And we were previously known as the S&C Alliance South. But the new title we have, South Rail Systems Alliance, that reflects the multidisciplinary design and construction activities we now undertake between ACOM, Network Rail, and CODAS Rail. And the Alliance is now split into three areas. The existing South Rail Systems Alliance, so the existing S&C South Alliance, won the 10-year contract to win for the S&C South Alliance, now called South Rail Systems Alliance. And we cover Western, Wales, South East, and Anglia. So we have quite an area that we cover. We did have London North West, LMW. We released that last year when we changed. However, our work bank is still pretty big, and we have a strong team to cover the area. As I said, systems, the key is there. We don't, in terms of SRSA, we don't just do track design. It is now OLE design and install. We do off-track works as well. We do some embankment works, do drainage, we do EMP, M&E. So we are multi-skilled, and this is good because we are a choice, one of the team of choice for our stakeholders due to Alliance's multidisciplinary engineering expertise. We're a one-stop shop, basically. They can come to for their design solutions and construction solutions. We've had 5 years already. Let's go to this, sorry. We've already had 5 years under our belt as the S&C South Alliance, delivering about 800 S&C units. And Our next two control periods, CP6, CP7, the next 10 years, we have more complex track and enhancement schemes. I personally feel this is because we've tackled a lot of the low complexity projects during CP4 and CP5, and now we're tackling a lot of the quite high complexity projects and enhancements going forward into the next 10 years. So typically the S&C Alliance is led by the P-Way team. The other disciplines sort of circle us. So we lead signalling, civils, electrification, power, third rail teams to produce an integrated design, again as a one-stop shop. Quick view there of our left end of work bank, so you can see for the S&C South Alliance, we were for control period 6, when we won it and changed to the SRSA, our work bank through the sort of control period headed up to about 553 units. So that's our target going forward, and you can see by the amount of jobs we have, we've already delivered over 100 units in CP6 year 1, all successfully, with no issues. Sorry, were issues, but however, we've delivered them successfully, no overruns. And into CP6 year 2 delivery, again, over 100 units we've got planned, and design is pacing ahead at the moment, both in the west and in the east, with the South Rail Systems Alliance. The great work bank, really busy, covering Western Wales, Wessex, South East, and Anglia. We're not just about S&C, we have a lot of enhancements as well. So Bristol East Junction is one of our big jobs that is being designed, and some stages have been installed already. That has 50 point ends to be renewed and 6.9k of day line renewal, which has been undertaken over 6 construction stages. So really good win, and that was a coming straight to the Alliance and saying, Alliance, can you deliver this, please? Which is great, a good lot of work, and we have Southampton, Old Oak, and HS1. We've been doing some work on those, and I'll talk a bit about Southampton going forward. We also now do plain line. We have 99 sites that were done in year 1, and another 148 sites coming up in year 2, and we've delivered 26 sites to date. So SRSA is about systems, and we aren't just about S&C renewals. We now cover enhancements, plain line, and are the team of choice for our stakeholders. So primarily we are there for our track renewal. We are known for that. Where possible though, we will see if we can do some line speed improvements, some heavy refurb work as well. So the term like for like is used far less, and as the rail industry seek to find efficiencies in delivering a better railway and putting passengers first, we need to adapt to the new initiatives that our customers want. We also provide opportunities to remodel S&C, providing greater flexibility, operational flexibility and capacity, and longer trains, longer platforms, and signalling flexibility. Again, all designed and integrated as an SRSA product. So that's the background. That is SRSA. Hopefully that tells you how we have changed from how we were in the S&C Alliance to how we are now as a systems-focused delivery unit. So I'm going to go through 3 examples of projects that I've been particularly involved with to date, with some of the issues and opportunities and solutions that we have been able to put in place to successfully deliver these projects. So Southampton Freight Train Lengthening, it's a project that's been happening for a while, a few years now. I know it started back about 2015, but it's coming to the end. Hopefully the final stage of this will be next year, next January. So it's 3 phases. First phase is Red Bridge remodelling. We then have line speed improvement phase, which is coming up at the end of this year, and the signalling commissioning, tying this all up at the beginning of 2021. And income design includes track, civils, geotechnical work, and power. And we have third-party OSL who are doing the signalling, so we have to integrate with them. There was some brownfield work and railway installation, a new rail installation. And that work is Redbridge, which has already happened. Yes, that was installed at the beginning of the year, recently commissioned. And we've gone from, if you look at the existing PSR diagram, we've gone from a single lead up to a buffer stop, just past platform 2 to the west. Okay, and we're doubling up. So the red beneath the PSR diagram, we're lengthening one of the sidings, siding 1, and installing a new siding, siding 2, and a hand point turnout at the end with a buffer stop. Okay, so simple bit of work. To enable the doubling, there are a number of constraints there. So with that, we had a number of constraints, including existing land. There's existing land to the south of the site. So we had to do some de-veg work. And because we're redoubling, we've also had to put in some lighting, new lighting columns, a new fence line, which you can see there, and as I said, the new hand points. A bit more detail on some of the constraints we had. So to the south of the existing footprint, there's a park. Okay, so there's a park just to the south, and Network Rail had to buy some land to get the second line in. Okay, siding number 2 to the south. We had the new line, new Network Rail boundary, new fence line as well, and there's a lot of constraints in terms of space then, but also existing equipment in the area. So there's an existing electrical substation, and as soon as you see, oh, there's a substation, you know there's going to be some kind of cabling coming from that substation. And in fact, you go to site and there's a number of cable troughs littered around the area. There you go. As part of the 4A design, we identified that there was an HV cable running, 650 HV cable running from the substation very close to the track alignment. And with that, we put a hazard on, and that hazard had to be taken forward into Form B design, okay, detailed design, and then into construction. This is where I'm going to hand to Paul Bell, because Paul dealt with this as the CEM at the time on this, and we can go through some of the issues we've had and some of the and lessons learned we've played on that. Okay, Paul. Okay, I cannot hear Paul.
Hello, is that better?
Oh, that's better. Excellent. Go for it.
So sorry. Goodness. Cool. All right. Yeah. So what I was saying to myself just a moment ago was so Southampton. I think what's also key to think about and remember in this job is that Southampton has been going on for a number of years. It's taken place with different organisations working on the design, and within those organisations, different people have come and gone, etc. So there's been there's a lot of knowledge out there in the job, and not necessarily all of it stays in the individuals. It's about the importance of documentation. So this issue was identified, and rightly so, in the Form A documents prior to me joining the company and taking the job on, but did result in some issue at the end. And we did a bit of an inquiry internally to work out, well, what could we have done better? And I just thought I'd share a couple of things with you on that. So the very beginning for us was the identification of the feeder route, and you can see on the slide there that the feeder route position was taken from a record drawing, and you can see that there. Now, the issues with record drawings, especially as you move away from signaling to some of the other power disciplines, etc., is that record drawings. Oh, brilliant! Record drawings are. Oh, hello. Sean's taken away my presentation. It's all good. Record drawings are they're subject to. I mean, they're only as good as the people drawing them at the time. What you tend to find is that signaling records, because signaling is quite a critical. They're all critical, but signaling is significantly critical. The quality of the records, well, varies depending on age, but they can be very, very good. And we do a lot of correlation to make sure that they're totally spot on. With some of the power records, they can be good, they can be bad. This is considered in the discipline as a good example of a record, but even that being said, it's only on an OS tile. It's not coordinated. The geometry is still in feet and inches, and it's not really what you need when you're trying to measure things to the millimeter. If we could go to the next slide. So, in good faith, we had put on the position, which is marked in orange of the cable based on the record information. The line in black represents the actual physical position of that cable. The cross marks are the positions where we eventually dug it out to find exactly where it was, and those are the positions that we surveyed on the cable itself. You can see there's a bit of a drift. This is about 700 mil, 600 mil towards where we want to put the new track, where that cable was actually found. Now, again, as track engineers in particular, millimeters can make the difference. As it was presented in the orange, it might have been something that could have been avoided. You can limit the dig off the sleeper ends and potentially avoid the issue. Where it was actually found was within the ballast shoulder, and action needed to be taken. If we go to the next slide. Cool. So for us, I mean, that was we raised a close call against the design because we needed to understand how we got to such a situation so late in the day. And a couple of things came to mind when we were looking at that. So in the event we had not undertaken those investigations and we'd put a bucket through that cable, it would have been a reportable accident and would have probably resulted in an HSE investigation. But beyond all of that, we could have run the risk of seriously hurting or killing someone or people in that action. As a slight aside, if you go to the HSE website, there's a brilliant video that shows you what a cable strike can do and what it looks like. It's not pretty at all. So burns would have been the obvious injury all the way up to death as a possibility had we not taken action prior to this moment. Again, if you think about the impact on the system, so we've been talking a lot about systems. We're no longer a track renewal outfit. We are responsible for the entire system. A cable strike, had that been a signaling cable or a telecoms cable, could have caused significant disruption over a large geographical area. And as well, there's third-party telecoms to be considered as well. I put there Acton mainline. There was an issue on the western at Acton where some fibre optic cables were damaged, and they turned out to be a live data link to some part of the stock exchange in Holborn, central London. So it's not just telecoms assets that are about. There are other people's assets as well, and stock exchange probably has bigger delay minutes than stopping trains on the western. So there we go. And then again at Redbridge, for our particular issue, we had to stop the main program of construction to investigate this cable. It was late in the design program investigating it, and that has a cost to it. Because of the position of the cable, the age of the cable, we ended up having to change the track alignment to move the track away from the cable position. So that's redesign, which is cost, but also trying to change things late in the day reactively imports risk and further risk. We manage those risks, but it's not a comfortable place to be in, and it's not where we should be when doing our design activities. And then there's a reputational damage as well. When that came up, I am accountable at the time because I was the CEM. It is my fault. People said some words to me, and in the heat of the moment, they were totally valid. But it's about reputation. So the old adage of measure twice, cut once, definitely applies. Check and check again. So if we could go to the next slide. So the lessons learned kind of bear that out. BIM and CAD ownership. So it's just something, and we still debate this internally in the Swindon office. The track drawing has always been referred to as a general arrangement, and dependent on the complexity of the jobs, we end up picking up other people's details, and rightly so. So a cable detail, as we were showing, that would probably sit right on a track drawing because it has an impact on the track activity. But we find ourselves as track engineers the custodians of a general arrangement that takes into account everybody else's design elements. And again, as we move from being a single discipline activity into a systems activity, we've had to rethink our BIM and our CAD strategy to say, well, do we need to, for smaller scale projects, be bringing in like a Master 500 or some sort of global referencing model to be able to manage these issues rather than it all sitting in the track design, and that's something we've been looking at going forward to try and avert these issues. Again, geospatial correctness is absolutely critical. It's a millimeter science with a lot of what we're doing, and we need to make sure things are correct that go into these models. And again, we must resist the urge to show uncorrelated information. Everyone feels it's the right thing to do, and it is the right thing to do to highlight these risks. But as I've put on a point a couple of lines down, if you think about advertising, advertising is so powerful. You can stick an image up on a tube, on the tube, or on a station platform, or on a bus stop, and that image, whether you're consciously taking that in or not, it goes in your head. And it can affect how you think and how you see things. If advertising didn't work, they wouldn't do it. It clearly works, and it's very powerful. And if you think about that in terms of our drawings, what we put on the drawing, it sends a message. It's powerful. It's got a title block. It looks professional. Now it could be a warning, it could be anecdotal information or whatever, but at a glimpse, at a glance, flicking through, we can take these things in, and if it looks correct and if it looks accurate, it could potentially be considered as being accurate. And I think that was part of the issue we had at Redbridge. We'd shown a detail that wasn't correct in a setting that made it look correct, and we got ourselves caught out. So you talked about the improved correlation of assets. I've said earlier, signaling assets are correlated as heavily controlled, how that's done. But do we, and it's an open question, do we apply that same level of rigor to some of the other services that we may encounter? Services we know are highly probable to be in the dig, we definitely go and we do our permits to dig and we try and find these things. But other assets which are around, but not necessarily directly in the dig or in our area, do we put that extra effort in to find out where those are to be sure that they're clear? That's an open-ended question there. And it's so we talked about the unintended consequences. And then yes, just to finish on that, a design solution in all of these things is always best. Interfaces, it's all about early identification of the interfaces. What are the things that need to be done beyond my discipline to make sure that my discipline can succeed and therefore the system can succeed? Documenting those, making sure that we've got action plans for dealing with those in a good time scale. And again, if we can design them away, that's even better. But early engagement, early rectification would have also saved us a bit of pain in this scenario. I think that's the end of my slide, Sean.
Okay, Paul, thank you very much. I have a message that my voice sounds slightly muffled, so hopefully it will be better now. I've just made some adjustments. I'm waiting for that person to come back and say yes. Right, so thank you, Paul, for your time. Excellent. Right, he said it's better, so hopefully that's good. Okay, so that's Southampton. As I said, lots of lessons learned from that that we've taken forward. The next project is Newport Station East. This is about good design versus compliant design. Two different things that came out from Newport for me. So Newport Station, let's hopefully go to the next slide. There we go. Okay, so Newport Station, this is a job that we installed at Christmas. Two crossovers and sorry, two crossovers, and a lead. There you go. I'll say it that way. Okay. All in about 56B. Trying to do a like for like in inverted commas on through bearers, but not modular through bearers. We're allowed to do some alteration to the layout, but we had to also stick with the signalling system and current operational moves. They had to be maintained. We had to do some line speed changes to accommodate the track alignment, to improve the track alignment. The biggest issue or constraint we had was integration with the Great Western Project, who was still finalising commissioning of the electrification through to Cardiff. Okay, so worth keeping that in mind. So although we're allowed to do some alteration, actually we are constrained. Okay, apologies. Let's get to that. Existing and proposed PSR diagram with Cardiff is to the west, Bristol to the east, and work was being done on the up main, the down main, down platforms. So up main, down main, up and down platform lines, platforms 4, 3, and 2 respectively. So the only material change, as I said, was the movement of the speed boards on platforms 3 and 4. Ooh. Okay, so go back to the constraints. DGWP early, as I said, big constraint. And the layout itself is a checked track layout. Okay, so there are check rails through the platforms due to the radius. We have a number of follow-on crossovers existing as well, but the design is follow-on crossovers, and the signalling constraints were actually quite tight to the point where we basically had to put in a derogation for some clearance, for a clearance point between 8091 and 8088B. The Great West Project had a plan to commission mid-December 2015, which pushed other constraints or unseen constraints in terms of design. So they had some test trains they were running prior to core possessions. They had to finish off doing their wire installation and fine tuning of the wire positions. And we had to obviously integrate our track design to what they were going to do, what the Great Western Project were going to do in terms of the OLE. And they kept hold of the source records because they were the dominant project. Other physical constraints, retaining wall on the north side of the railway and Thomas Street underbridge. Again, we tried our best, and we did try to ensure we didn't have to do too much renewal over the underbridge. So gives you the idea of some of the seen constraints and the unseen constraints we had to deal with. So with that, the first, we tried to do a like for like renewal here as best as we can. And you can see from that chart there, the toe movements were pretty minimal. The two biggest toe movements we had there were 8090B and 8091. So I'll go back to that. Okay, so 809B in platform 3, okay, and 8091 just to the west of platform, sorry, to the east of platform 4 on the up main. Okay, so although they look small movements, they're considered minimal in terms of signalling and early interfaces. And we had also had to ensure we kept minimum movement because of the OLE. The project team actually managed to value engineer the requirement for 4 number OLE new structures on top of TGWP structures, 4 new structures, and we managed to reduce that to 0 structures through the design. Because this would have been additional cost that hadn't actually been accounted for, and time accounted for within the renewal. Okay, so that gives an idea of the tow movements, 8090B, 8091s, and the minimal tow movements to accommodate the design. So, bit of a larger cutout there of the GA. Okay, so there's crossover 8090B through to 8091s. And what we try to do here is limit the impact to the platforms, okay, platform 3 and 4, ensuring that adjacent turnouts also could be fitted. So 8090A on the up and down platform, that was fixed also generally to the OLE. But we also had to obviously ensure compliance to the track standards 2102 and 2049. The other thing we had to ensure understand was the crossover, the usage of that crossover, and the passenger comfort. And I think here was where it was called a crossover. We should have taken more note of, actually this is really used more as a through route than a crossover. Coming to the manufacturer's layout, so that's what the manufacturer's layout looks like, and you sort of zoom into it, and it looks great. They're both left-hand switches, which again should have raised a few eyebrows when we looked at the alignment. And another blow up there of the layout. So we have 2 similar flexure left-hand turnouts into contraflexure. Sorry, a similar flexure turnout into contraflexure left-hand turnout, and 0 straight elements on the through route, giving us back-to-back transitions and reversing radii. So with this, we should also have had a view on how the turnout will look and ride. Looking at it on paper, you look at it and think, okay, it's compliant, the design works. We're to 102, to 2102, and to 2049. All of the and the calculations work, the maths work for that layout. But on paper, you cannot really understand how it looks and how it rides. This is a photo from the manufacturer's yard provided by the very concerned Network Rail PE. And it's notable the kink past the crossing of 8090B, which is the crossing further on that you see. So you can see there's and I say kink in inverted commas. Actually, that is a reverse transition. So you look down that, you've got one transition from the turnout going into a crossing, and a transition just prior to the crossing. The PE rightly asked for a check to be immediately done while she was at the manufacturers, just to make sure, number one, we had provided the right P-way design model, and we do a proper check of the geometry through there. Okay, so we got onto that immediately and found actually it is correct. What we've designed is right, it's compliant, and we've provided the right information back to the manufacturer. From this, we decided that we need to learn from this, lessons learned and a design response, because we had to present something to the customer, the RAM, before it was installed. Again, it's compliant, but we need to show what design decisions we've made to come up with that layout, which we did. We put something very comprehensive, which went into the Form B, back to the RAM. And we also put in other measures for the RAM to assure the RAM that we had done the right thing and compliance was there. So we now undertake independent Cat 3 checks on different layouts, so not the norm. Okay, we won't call them novel, but something that's a bit different and we will send that now for a Cat 3 check. And we did it with this, although not required under the track assurance standard, we decided to. We also did an independent peer review. So we also now do independent peer reviews of designs. So on top of the Cat 3, there will be another review by a senior track engineer. With this, we also, and we have done it with other designs going forward, we put in a detailed extract on the DGA of that layout. So rather than cluttering the core GA, we would do a blown up extract where we will put all of the geometry onto that and note any issues in terms of check rail positions or twist positions, etc. Okay, so that's something we've learned from this is, don't take it as given because the geometry works that you're going to have a good design. Maybe compliant, it doesn't necessarily always mean it's good. And one thing I learned from this is don't turn up on site and expect it to be any different. Okay, so that's on the day of install. I stood there, took the photo, looked at it, and thought, okay, well, that's it's not going to change, is it? Okay, from what I know, it's been installed well. It rides. It does actually ride well because it's probably going slower into the platform. And actually, in the end, you look at it, and it's a good job. But again, compliant design versus good design. So that was Newport. Let's get to the next slide. There we go. So final one, I seem to do all of the Wales jobs. I do enjoy the Wales jobs, to be fair. This is Cardiff Station East, which was put in the ground in April. That's for the of May. And Cardiff East S&C renewal, again, a like-for-like renewal, quite straightforward, a crossover and a single lead, and plain line, and some platform works as well to achieve the compliant crossballs in the vicinity of the track design at the platform. Why did we go for like on this job? Because of the site constraints. This was a very, very constrained site. A number of under bridges, recently renewed S&C that we've from CASA project that we've had to tie into, and as I said, the station platforms that we've had to tie into as well. Just a quick view there of the existing and proposed layouts, no change in speeds. And this just shows you a visual of the constraints. So we have a number of underbridges, Penrith Road underbridge, West Canal Wharf underbridge, 9200B S&C, which is an existing recently renewed lead that we had to tie into, and the platform 3. And our work for 9047A and B and 9046 was on lines E and D, line E going into platform 3. Penrith Road underbridge is a girded underbridge. Okay, so there are girders that you can see that on the photo, but it also has no ballast step. Okay, so we, although we could do some lift in there, we were constrained obviously by the platform tie-in and trying to make sure we don't do over and above the work where we were scoped to do through the platform. We did do a number of trial holes through Penrith Road underbridge, and these are trial holes which gave us our result for the ballast step. Was also to give us an understanding of what the underbridge construction type was also. And here's a couple of pictures of the bridges. So line D, ballast retention there. So part of the work there was to renew this ballast retention on Penrith Road through lines E and D. So that's part of the scope, which was fine. And as I said, we had to do enough, do some trial holes to understand what was there. And civils do a visual inspection of the existing ballast retention system that was there. Clearances through line D, very good. But it was noted, especially on, there you go, line E, clearances were not as good. And actually, there were additional elements to the underbridge. As you see, there's a bit of a brick kind of wall, I'll say, but there's some brickwork there just beyond the girders through line E. So line E, two issues. It was a very tight, needed to lift the ballast depth slightly, and the existing clearances through there very, very tight. So with that, we need to do some more investigation, especially in terms of the how we're going to put the ballast retention back, not compromise the clearances, and what effect any lift would do to the bridge and to the ballast retention system. For this, we went to 7073, the group standard, and for positioning of infrastructure and defining and maintaining clearances. And we looked at this in terms of the lower sector infrastructure gauge. So we provided this, so track designers provided the civils designer with this key criteria: ensure that the ballast retention system sits outside of the lower infrastructure gauge. So that was one a constraint or criteria for their design, and we also ensured that they understood, what we needed to do for track design and for clear route to satisfy maintaining clearances as well through there. Right, so we gave them some key criteria to design the system to. The design that Civils proposed was similar to an existing design on adjacent line C. This is where you have a plate placed vertically against the girder stiffeners and a diagonal grating that then goes from the top of that plate attached at the top of the plate with an angle cleat, okay, and then interfacing back to the girder. So we decided, yeah, we'll adopt that solution. So you can see that there in red. We'll adopt that solution. We feel we know enough about that bridge to be able to say, yes, that solution will work. And again, the key criteria, trying to keep the new plate system, the ballast retention system, outside of LSIG. With this, though, we had to also consider tolerances. So civils construction tolerances are in excess of track construction tolerances. As track people, we work to millimeters. Civils, not so much to the millimeters, maybe to the tens of millimeters. So we had to factor that in, and also factor in survey tolerances. So in clear route, with this 1 millimeter tightest clearance that we had of the system, the ballast retention system, to LSIG, we had a 1 millimeter clearance. In clear route, however, it was foul. So there was actually a gauge clash there in clear route. So we said, okay, for survey tolerances, what does 14 millimeter tolerance give us in clear route? And that produced positive clearances. They were still reduced, but they were positive. And this is what we said we would go forward with in terms of the design. So a lesson there is understand fully tolerances and see if you can get a balance between all tolerances to do with each discipline and survey. Some of the photos from the day of the races, a number of obstacles were encountered during the work, which included the brickwork. So although we knew where the brickwork was, we knew it was below and out of the way of LSIG, what hadn't been taken into account was physically getting a machine through there. So that was tough. That delayed put some time into the program just to get the machine in and out through the bridge. But the other issue was the closeness of the end of the timbers to the bridge as well, to the brickwork. So we did find a solution in the end for both, which I'll come to in a second. But these are things that we found on the day. And as I said, we did a number of trial holes, and we actually went back prior to the core to do additional trial holes because there was opportunity to do it. And we still didn't find some of these additional obstructions which caused some headaches during the dig. There was only one opportunity after this to get in, so these were the core works where we wanted to put the ballast retention in. The other opportunity was the weekend after. So as an alliance team, we got all the designers and construction team together and said, right, we need a solution that will solve this issue. So more there, that was corrugated plate that we found above the deck. So we revised the ballast retention design, again, making sure we kept to the key parameters and criteria that track specified. And the solution was actually, was very good. We managed with this solution to be able to put the plate closer to the girder, thereby improving the clearance through the bridge girders. And the design also had to take into account the additional lateral force and track resistance, because this was going to be track that was going to be stressed throughout the bridge. So we used some SHS sections, some square hollow sections, steel hollow sections through the girder, utilised some of the existing lugs on the girder as well for some extra lateral force resistance. And that, as I said, that gave us some additional clearance to the girder. This was the outcome. So this was the finished product. Line D is on the left, line E on the right. And it's a very, very tidy solution. Gauge-wise, absolutely clear, absolutely fine, absolutely clear. And the track was stressed through there, and the track is holding well. We obviously had to do our inspections post core works just to ensure that when we stressed it, it was okay, there was no movement, and it's sitting fine. And I'll say this for me was it was an exercise in getting an alliance decision on how to get about the issue. So as I said, we undertook some So what we learned, undertake more trial holes, do some trial holes and then do a bit more, just to be sure we're absolutely satisfied we understand what the existing situation is. Peer review of civils designs to answer non-civils questions. So me as a track man, I was a CEM for this project, but I actually sat and studied the civils designs, and I came back and asked questions in a system and track point of view rather than a civils point of view, especially in terms of the clearances and how we assure the track PE and the DPE and the team that the civils have taken into account what the track is doing and how the track is designed and performs. Recognise and agree design and construction tolerances, as I said earlier, ensure they're agreed and they are implemented in the design appropriately. Safe by design considerations should include all plant provision. So again, we as the Alliance, we missed the plant that had to traverse through the structure. This is now something that will be taken into account going forward for all of our projects. And if it appears tight, do something about it, okay? So you may say, oh, it's low and it's out of the way, but actually it's always worth doing a second check to make sure you have got a compliant, which is positive, structure passing clearance in line with 7073. So there, and something else we have started doing on most of our sites now is we will do a clear route as-built gauge analysis prior to opening the line. So we won't wait till the next possession. We will get in there, draw in the core works, receive any of the laser sweep detail, and we'll carry out the clear route analysis and provide that back to the team to give confidence that we can open the line safely back to traffic. Okay, so that's it. Thank you for listening. Just an example there of some of the pitfalls, but also the opportunities and solutions we have done as the Alliance. As I said, 32 years in the railway, and I am always learning, still learning, and hopefully some of the stuff I've shared with you is new learning opportunities and opportunities that you'll take on board. Okay, thank you for listening.
Okay, thank you, Sean. Right, we've got a few minutes for questions. So I believe the chat line now is open. So if you want to post your questions, I will relay them to Sean. So waiting for others to post their questions, Sean. I've got one regarding Newport.
Yes.
You talked about good design versus compliant design.
Yeah.
Considering all the constraints on the scope of your work, what other options did you have to change the geometry in this particular instance?
Yes, so we had quite a few options. What we do is as soon as the PRS comes over, and hopefully that will come over with a Grip 3 drawing, we will interrogate it and see, not change it, see where we can enhance that design. And this was looking at, looking at recanting, moving the crossover slightly to away from the platforms. Looking at the intervals as well. The final track interval that we had on the up and down main, we actually closed the interval from the existing interval, which was quite wide, and that was necessary to get rid of the cant through the platforms. So one of the options we had early on was to keep the track intervals where they were and move the crossover to the east towards London, which didn't work because you couldn't get rid of the cant enough in the platforms, but also the OLE modifications were huge. So yeah, we had about 3 or 4 different options, and the minimum amount of work was the option that we chose. One of the issues we did have with that was the signalling. So I think I did mention that we had to put in a signalling derogation for clearance because of tightening up the interval. Again, the solution we found wasn't a design solution, it was actually a standards solution, looking at the standards in a different way, which was approved by the DPE and the PEs. So that was good, and that was our track guy. So, well, actually, you can use this value and you're still compliant. So yeah, we always try to get the Grip 3 design, do some, interrogate it, see if we can enhance it, not change it drastically, enhance it, because otherwise we're doing the Grip 3 job again, and present that back, through our design log. So, is this the optimum solution we can have, and make sure that's agreed with the project going forward.
Okay, thank you, Sean.
Yeah. Any questions?
I haven't seen any questions coming back through the chat yet.
Okay.
So I think you gave a great level of detail in your presentation. That was good.
Good.
So maybe just a few thoughts then to close the meeting,
Yeah.
if there's no other questions. First, thank you very much for coming and do this presentation, share your experience. That's very much what Permanent Way Institution is about and what these meetings are about. On the example you've chosen, I think every designer and builder can recognize those issues. Certainly, issues about positioning of services is critical. You mentioned, for safety and for operations. My experience in working on Southern for a period of time was also with 650 oil field cable that, if damaged, could actually create a big environmental damage. So there's a lot of thoughts to be put into knowing where cables are positioned. Also, I guess we are all aware that whatever we leave behind is going to be the source of information for future projects. So we also need to be putting a great focus on our own records when you produce them, being aware that maintenance and other projects at some point in the future are going to be using that. As there's no other questions coming up, I would like to thank you again, Sean, and thanks everybody who's attending the meeting today. Again, a great turnout, so thank you very much. Stay safe, everybody, and we'll see you in 4 weeks' time. Yeah, bye-bye.
Thank you, Jeff.